Hello student, this is Suman Sharma from SPM Sinidih and this is the first video for class 7. And in this video we will study about motion and time. Student, in your surrounding you see so many things, so many objects. Some things are in movement and some are not. When the objects are in movement, then we simply say that the object is in motion. And when the objects are not in movement, then we say that it is at rest or remains stationary. But if we have to define the term motion, then how we will define the term motion? When the object change its position with respect to time, then we say that the object is in motion. You already know it because you already studied in class 6. Now here are some different types of motion. First is the motion along a straight line, that is rectilinear motion. When an object travels along a straight line or move along a straight line, then that is called rectilinear motion. Here are the image or the example for the rectilinear motion is also. Now this is the example for rectilinear motion, that a motion of a car on a straight road. Now the second is periodic motion. When the object repeats its motion after a fixed or regular interval of time, then it is called periodic motion, and the motion of a pendulum is one of the example of periodic motion. Now the third is circular motion, and the example for the circular motion is the motion of the earth around the sun, as you can see here. This is the example for circular motion. Now in the next slide the topic is speed. Students, first of all have a look of this image. In this image there are 3 cars, and this purple car is at rest because it is not in motion. Its speed is 0 meter per second, so it is at rest. And the another car is of color blue, and the another is of color green. Now while comparing or pay your attention in the image, you can simply say that the green car is traveling fast and the blue car is traveling slow. So the student, speed is simply the word which tells us how fast or slow the object is moving. But if we want to calculate the magnitude of the speed, then we need the 2 quantity. First is the distance and second is the time. So for the calculation of speed, we have the formula of speed is equal to total distance covered by total time taken. Now as the example is given that if a car covers a distance of 100 kilometers, then car cover a distance of 100 kilometers, and in covering this 100 kilometer distance, the car takes the time of 1 hour. That means the time taken is 1 hour. So the speed of the car becomes 100 kilometers per hour. Now there is also a bus. The bus covers a distance of 50 kilometers. So the distance for the bus is 50 kilometers, and this 50 kilometer distance is covered in 1 hour. So the time interval is 1 hour, and the speed of the bus becomes 50 kilometers per hour. Then if we compare these 2 quantities, this is for car and this is for bus, then by comparing these 2 quantities, we say that the speed of the car is more than the speed of the bus. By this way, using the total distance covered and the time taken, you can calculate the magnitude of the speed, and by comparing these two, you can say that which object or the which vehicle have more speed than the other. Now, in the next slide, the topic is uniform motion. In the previous slide, you just learned that how to calculate the speed. So, if the speed of an object is constant means the speed of an object is not changing, then it is called uniform motion. Here it is also written that the speed of an object is constant means not changing, then it is called uniform motion. The best example for uniform motion is that the clock. We know that the hands of the clock move with constant speed. Its speed is not changes. Then this is the best example for the uniform motion. You can also give the another example of uniform motion also as the earth rotates around the sun. This is also one of the example of uniform motion. Now the next topic is non-uniform motion. The non-uniform motion indicates that if the speed of an object keeps changing, then the motion is said non-uniform motion. To understand this non-uniform motion, suppose that students, you are going to market. When you are in your car and your car is on the main road and the road is very clear, means flat. That means at that time the speed of your car is high. But after traveling some distance or after some time, there is a red signal. Then after noticing that signal, you must slow down your speed. You must slow down the speed of your car. That means at the initial position, the speed of your car is high, and after some time, the speed of your car is slow, or your car is just stopped. So that the speed of your car keeps on changing. So that type of motion is called non-uniform motion. You can also give so many examples of non-uniform motion also. Now, in the next slide, the topic is measurement of time. Time is measured by using clock or watches, and the clock and watches makes use of periodic motion. Here are some images for the clock. First is the wall clock, second is the table clock, and third is the watches, which is wrist watch. Now, the next topic is simple pendulum. Here, the animation for the simple pendulum is like this. Now, students, a simple pendulum has a small metallic bob. Suppose that a simple pendulum has a small metallic bob like this, and it is suspended from a stand by a thread. Now, a thread is tied here and it is suspended with a stand. If the bob is taken to one side and released, suppose that we are pulling this bob in this side, and after reaching this position, we just release the bob. Then this bob moves to and fro. Then the bob moves like this, as you can see in the image or the animation also, that it moves like this. And this to and fro motion of the simple pendulum is called periodic or oscillatory motion. Now students, you have to read and write this definition of simple pendulum and try to understand that how the simple pendulum works. So students, I hope this is enough for today. So try to understand all these things. Thank you so much.